So I hope that screen is also available to both of you now. So if it is the case, then we will just start today's session. So first of all, before proceeding to today's session, we would like to I would like to understand. Is there any problem in what we have discussed yesterday? Because now we are trying to climb up step by step, and it is important for us to understand whether we have covered the previous step or not. So meaning thereby, as we have started from the process of research, then we have come on to how statistics comes into picture, then we have come on to how to decide sample size, and now once we have decided sample size, we will try to understand how to collect data. That will be our next leg of it. And in the process of understanding how to collect data, we would essentially be trying to understand what are the scales on which we measure the data. Alright, what are the scales on which we measure the data, we collect the data, and then maybe after this talk we will be trying to understand how to develop a questionnaire using those scales. So this is, we have lined it up, and once you have a questionnaire before you, so we will be covering a lot of the portion that I have thought of to be discussing with you. Then this questionnaire having with us, then we will be trying to understand that once we have this questionnaire, we will get it filled from the field, and once we have this data being filled up by the people or by our respondents, then how do we analyze it? So I will be trying to take some sample data, and on that sample data we will try to apply some tools and techniques. And just to give you a food for thought, the tools and techniques which I have lined up for you would be t-test, ANOVA, that is something which we call as analysis of variance. After ANOVA, we will be trying to discuss something which is called as factor analysis. And this is something which we have lined up, and we will maybe also try to understand regression analysis. So these are the terms that you would have heard about in statistics classes whenever you have gone through them. So we'll just try to understand all these concepts, but here it will be little different in the sense that I will be trying to touch upon the practical aspects of these tools and techniques. Meaning thereby we will not be going into, when I'm talking of regression, I will not be going into y is equal to a plus bx, which is the regression line, but we will try to understand what is application of this regression analysis in understanding or evaluating and analyzing the data and how to interpret it. So that will be our objective. All right, so this is something that we will be trying to do. So now if you have something to discuss from our last session, then please let me know so that we can today start discussing our next topic, which is scaling. Okay, so it seems that it is going good till this point. So now let us try to understand today's thing, which is measurement, scaling, and questionnaire. So questionnaire is something that, as I've already discussed with you, that we will try to cover it in our coming sessions. Then today we will start from measurement and scaling. Measurement is something that you would be hearing a lot about, but in research, the meaning of measurement would be little different from what would be its literature meaning. So there is one word which is called as measurement, there is one word which is called as scale, and the scale word has multiple meanings into research. So when we will come on to questionnaire thing, we will also come to know that questionnaires are also called as scales, and when they are called as scales, that also we will try to do. So now if I can have an idea from both of you, if you have any idea about what would be the difference between measurement and scaling, what is measurement and what is a scale? So do you have any vague idea or any fair idea about these two things? Measurement and scaling, what these are? Manjula is trying to attempt it. Measurement and scaling, that is what we are trying to discuss. Maybe you would have done it in some of your statistics classes. Yes, that is fine. That it may be used as a range to measure. You are right, Manjula, to some extent. But let us define your response so that we can actually understand what it would be in research terms. So, whenever we are discussing anything here in this class, we will be talking it from the point of view of research only, as our topic of discussion is research methodology. So, research methodology would mean what all methods do we apply and do we choose and do we select out of the available methods to carry out our research work. So there is measurement for you. Measurement is defined as something which is a process of assigning numbers or symbols to characteristics of object according to certain pre-specified rules. Now, let me try to elaborate onto this definition of measurement. Now, suppose there is an individual and you are trying to measure his attitude. Now, let's call it as his characteristic. All right. So, attitude obviously is characteristic of an individual. So, this is something that we are trying to measure. Attitude is a characteristic. So, if I say that he has a good attitude or he has a bad attitude, that again is his characteristic. So, if I have to rate him on to 1 to 10, suppose, then what I will be doing, I will be doing nothing but I will be assigning a number. All right, I will be assigning either 1, I will be assigning either 2, I will be assigning either 3 or 4 or whatever, or maybe I may also assign any symbol to it. So whenever I am in a process of assigning any number, all right, to any individual's characteristic or to any object, maybe it is an object, maybe it is a car that you are trying to measure speed of it. All right, so when you say that a car is moving at a speed of 60 kilometer per hour, so 60 is something that you have assigned to this much of speed, and these things are done on the basis of some pre-specified rules, and these are important to understand. So if I am trying to measure anything, I have to have a pre-specified rules for it. Now, just to give you some example, now suppose no one on earth is going to stop me if I measure the intelligence level of any individual on the scale of 1 to 10, 1 being best and 10 being worst. All right. I can also do it same if I have to take it as 61 to 70, whereas 61 is bad and 70 is worse. All right. So this is something that I can take on. So there has to be some rules which says that how to measure it. You can also take 10 as to be the best and 1 as to be the worst. So you have to first define rules according to which you are going to assign numbers to characteristic of any object or of any individual. So that is something that we call as measurement. So as it is coming out to be an important factor that whenever we are thinking of assigning numbers to anyone, so we are talking of some standardizations, and these standardizations has to be uniform. Now let us take that example that we have been trying to understand since the beginning of our this session, and that was that height of the class that we were trying to measure of 58 students. Now suppose that we are trying to measure height of the class in centimeters. All right. Now this is the standardized norm that we try to measure it, and it has to be uniform also, right? So this proper way of measuring height of an individual has to be standardized so that things can be compared. Now, one of the major things that actually is important when we are thinking of a concept such as measurement is because we are not measuring anything just for isolation. We are measuring it so that we can make a meaning out of it, and that is important to understand. So when I say that his height is 170 centimeters, it is a meaning to me, it has a meaning to me, all right, and maybe I will use this meaning to interpret something. And many a times it so happens, understand it carefully, that when we are trying to interpret the meaning of these measurements, then we are eventually in the process of trying to compare it with something. So which means if suppose I say that he's a taller man, so he's an handsome. All right, taller means handsome. So eventually, inherently, back to the mind, I'm just giving you a very plain example. In research it happens a lot. I do not measure anything just because I am measuring it. I have a reason to measure it. So if I'm measuring rainfall, the example that we took some other day, and if I'm measuring the crop production that has happened, so I'm not measuring crop production just because I want to know what is crop production. Obviously I want to know what is crop production, but I have a hidden agenda behind it. I would like to know that this crop production that I'm talking about, How is it related with the fertilizers? How is it related with the rains that has taken place? So this thing when we have to compare, then this standardized things even becomes very important. All right. So there are times, now suppose you cannot compare two things which are measured in different units, and for that we have something that is known as coefficient. I'm sure that you would have heard this word coefficient. Coefficient is a unitless thing. All right. Now just to give you one more example, now suppose variability that we have been talking about since beginning of our these sessions. Variability is something that we measure by means of standard deviation. All right. So suppose we are talking of height of our students in this class of 58. Now my height may be varying with the standard deviation of 5 centimeter. Now that is something that I have come to. Now suppose the same 58 students, I am trying to measure their intelligence level, and now I say that what is standard deviation of their intelligence level, and I say that the variability in the intelligence level of these students is varying by a standard deviation of 5 points. If at all I have to compare these two things, which is intelligence level and maybe their height, which at many times we may require to know, then I cannot compare these two things. All right. And to compare these two things, I need to have both of them at same level or maybe at same units, which obviously they are not, because one is measured in centimeter and one is measured in some other points which measures intelligence level. So as they are measured onto different points, I cannot compare them. So for these things, the solution is that we should try to standardize the measurement as long as possible. Two, even if that doesn't work, then we tend to do something which is known as coefficient. So I will have standard deviation coefficient. Now this is a coefficient which will vary from 0 to 1. So a value near to 1 would mean there is a lot of variation. Value near to 0 would mean there is little variation. Same way, the variability of intelligence level, which by now I was measuring into some points, I may convert it into some coefficient which is a unitless thing. So coefficient by definition is unitless. So I would say that it varies from 0 to 1, and a value near to 1 would mean that his variability of this class in intelligence is too high, and if it is near to 0 it is too low. So now when I have these two coefficients which I have standardized, I can compare these two things. All right. So this is something that we mean by getting the things standardized of measurement. So if we are measuring weight in kilograms, so let us measure it in kilograms only. So this is the second point that is mentioned onto the slides, that rule should not change over objects over time. We should not be changing rules too frequently, because ultimately it is going to have a lot of impact. So when the world is becoming a global village, we need to you know have the data from every quarter of the globe, and then we have to compare them. So when it is the case, we should not be changing rule too frequently of measurement. We should be trying to make it as standardized as possible. So this is something which is measurement here. Just reiterating that it is about assigning numbers or symbols to any object, or to be more precise, to the characteristics of the object. That is something that we talk of measurement. Now we will be talking of scaling. Now suppose you have measured something. Measured something would mean you have assigned a number to a characteristic of some individual. Now you are trying to measure intelligence level of A. So you have get a thing from 0 to 10. So now you say that he sits at 2. So you've assigned a value of 2 to him. Alright, as per some pre-specified rule, and that 2 is an isolated thing for you. Now this is just a number that you have assigned to him. A scaling would mean to create a continuum upon which you place a measured thing. So which means if I am having 2 as intelligence level of any individual, then I will be having a scale which would say 0 is least, 10 is better, or maybe 10 is least, or 1 is better. So this is a continuum, and on this continuum I will be placing my measurement. Alright. So if he stands at 2, I know on this continuum where I have to place him, where I have to locate him, where I have to put him, and this is about scaling. Alright. So this is difference between measurement and scaling. Measurement would mean assigning a value to characteristic of any object, whereas scaling would mean to locate, to put or to place this assigned value onto some continuum, which actually makes us to do a relative comparison of two things. So on this scale, one may be placed at some point, all right, and on this scale one may be placed at this point and another one may be placed at this point. So now looking at this scale, we can actually talk about how much is the difference, right, and how much is one better from another one. So this helps us in doing comparison analysis, and this is something that we call a scaling. As is mentioned here, on an attitude scale from 1 to 0, each respondent assigned a number from 1 to 0, and that is something measurement when we are assigning numbers. So 1 being extremely unfavorable, 100 being extremely favorable. So measurement would be the actual assignment of number, and scaling would be the process of placing these numbers onto some continuum, and this is something that we call as scaling. How these things are important in research is, though they are very basics, but yet has to be understood fundamentally, that whenever we are trying to measure anything from respondent, we are actually assigning a number to the characteristics of his, which is measurement, and when we are measuring it, we are going to place it on a scale. So you would eventually see when we discuss it in our further classes that scaling is something that we vehemently use when we are talking of research. So we will have a question, and on that question we would eventually create a scale. All right, we would say that okay, 1 is highly accepted and 5 is really not accepted. Then you have to measure the characteristic of an individual first, and then you have to locate him onto this, and that is how we tend to do measure the data or to collect the data. This is essentially difference between measurement and scaling. Now let's come on to the real thing now. So when we talk of scales in research, we have essentially four kind of scales, and every kind of data that we can collect or we can think of collect comprehensively from wherever in whatever form actually has to be documented or has to be transcribed in any of these four forms. So one form would be nominal, another form is called as ordinal, another form is called as interval, and fourth form is known as ratio. Now these scales are important to understand, since I have been discussing since beginning that it depends a lot on how you are asking the questions. It is very important to know how you are asking questions, because a lot will depend on to your way of asking the questions, that whether you can subject this question to certain tools and techniques. Now I have been discussing this thing a lot about that if ANOVA has an assumption to it, then that assumption actually has to be fulfilled before applying ANOVA. So if ANOVA says at all that I want my dependent variable to be on metric scale, I want my independent variable to be on non-metric scale, now this assumption has to be met in any case. So if you know that I have to apply ANOVA to arrive at so and so result, then you better get your data ready or measure your data or collect your data at the first place on these scales only. So that is where these scales are important to understand. Now when we are talking of these scales, nominal, ordinal, interval and ratio, one more important thing about it to understand is that we will be trying to study them in an ascending order, in a chronological order you may say, meaning thereby that nominal scale has some properties, all right. So then we will be talking of ordinal scale. Ordinal scale has the properties of nominal scale, but something has been added to it, right? So then we talk of interval scale. Interval scale has properties of nominal and ordinal. At the same time, something has been additionally added to it, and hence it becomes a little better scale than nominal and ordinal. And then when we talk of ratio scale, it is something which has the property of all the above three scales, but it has some fundamentally, by its definition, some properties which none of the above scales are having. So we say that ratio would be the best scale to be applied whenever we are trying to collect the data. But yet nominal is important, ordinal is important, and interval is also important. And you would find that whenever we are talking of research, as in next class we would be trying to discuss questionnaire formulation, there we would be looking at some questions which are actually measured on interval scale. So to be very frank with you, 80 out of 100 questions would be using interval scale to measure consumers data. All right, so this is how we tend to do it. Now let us try to understand the fundamental things about these scales. So first of all, before beginning that, there are some terminologies which you should be familiar with, and these terminologies are, you must have heard me saying metric scale, you must have heard me saying non-metric scale, you must have heard me saying categorical scale, you must have heard me saying non-categorical scale. There is one more terminology, that is continuous scale, and there is something which is known as non-continuous scale. So let me make it clear to you upfront that what these terminologies are and how are essentially which one is falling into what thing. So I again have to take you back to Excel, wherein I would like to show you where we can fit all those four things. So first of all, let me talk of non-metric scale. All right, and when I say non-metric scale, I would essentially be talking of any of these four things, and now I will be talking of metric scale. Right, now these are two broad categories of scales. Now non-metric scales actually are also called as categorical scale, right? So because many a times, why is it important to understand this, is because many times it so happens that we would come to know, or maybe there is whenever we are looking at a proposal, we would come to know that only categorical thing is mentioned. So we would not know whether it is metric or whether it is non-metric, because essentially statistics talks of these tools and techniques in metric and non-metric terms. So we would know and we should know that which one is what. So metric scale is also known as non-categorical scale, right? So when we are talking of non-metric scale, now there is something more which we have discussed, and that was continuous thing. So non-metric scale is also known as non-continuous scale, right? And this is something which is known as continuous scale. So these are the terminologies. So when we are saying non-metric scale, so essentially we are talking of categorical scale or non-continuous scale. So they all three mean same. So when we are talking of these things that we have done now, so they actually, these all four scales that we've just looked at from the surface level, they would essentially be falling in these two categories. So when we are talking about non-metric scale, nominal scale would be a part of non-metric scale. Ordinal would also be one of the types of non-metric scale. So rest of the two, which are interval and ratio scale, they are part of metric scale. So this is how we tend to define it. So we have two broad categories, non-metric and metric. So metric is also called as non-categorical and a continuous scale. Non-metric is also called as categorical and non-continuous scale. Non-metric are of two types, nominal and ordinal. Same way metrics are of two type, interval and ratio. So this is the broad classification that we talk of when we talk of scales. So let us get back to our usual thing, which is our PPT. Now the pictures which has been shown on the right hand side of the screen essentially tells us what these scales are. Now nominal scale would mean to assign some numbers which are unique in itself. So when we say that there is this class of 58 student number 10 has a roll number 1010. So this 1010 which has been assigned, that will be unique for him, and that is something which is used to identify him, and that is something that we call as nominal scale. So nominal scale basically is used to identify someone, to assign a number which is not given to everyone. So ration card number, all right, so pen card number, so a roll number into the class. So if we are talking of some race, rank given to anyone, all right, so he is his first number. So that is something that we call as nominal scale. So it is something which is essentially about identifying the individual, right? So this is something nominal scale. Ordinal scale, as the word talks about, it has an order thing into it. So that will talk of who is first, who is second, who is third, or if you are talking of say intelligence level, who is more intelligent, who is less intelligent, who is even lesser intelligent. So when we fix orders of the people, when we are talking of chronology of the event or of the characteristic, so characteristic here is intelligence level, then we are talking of ordinal thing. Interval thing would be having a scale, all right, and then measuring something onto that scale, which means now we are essentially when I place something, suppose there is a scale of 0 to 10 and I place someone at a point of 8, alright, I would essentially be talking of that his thing is 8, but then if I have pre-specified rules as we have discussed, then I would be knowing whether 8 is better than 6 or not. So in this way, it actually behaves the characteristic of ordinal, because now I know whether 8 stands ahead of 6 or 8 stands behind of 6. So it has the characteristic of ordinal scale, and someone who is at 8, I can also identify him by that 8 thing if it is not given to multiple individuals, and that is how it also behaves the characteristic of nominal scale. Ratio scale would be something which is absolute in number. Absolute means, so I would say that but to talk of fractions, it will actually be very absolute. You are 32 years of age, you are 32 years of age, that is something which is ratio scale, absolute thing which is as it is, alright, which is not changed, that is ratio scale. Let us try to understand some technicalities of it. What are the characteristics and properties of all these scales? First, nominal scale, as has already been discussed, that this serves as label, as tag of identifying and classifying the objects. So you give a roll number, you know that I need not to know his name now. Just by looking at his roll number, I can identify him, I can classify him. Alright, so this is nominal scale for you. Now in research, when we are talking of, when we ask the name of the respondent, alright, we talk of a nominal scale. Many a times it so happens that two respondents are of same name, then that would not be used as something by which we can identify, you know, the respondent, but yet it will be nominal scale, because we can combine two nominal scales and then make it a comprehensive nominal scale. So we say that name of the respondent along with father's name or maybe date of birth, that becomes a nominal scale. So date of birth, if you talk of, we expect that people would have a different date of birth combining with name and all, so that would become nominal scale in research. So when we are talking about nominal scale, it has a strict one-to-one correspondence between the number of objects. One-to-one strict correspondence would mean only one people should have that number which is assigned into nominal scale. So we assign a serial number. Essentially how we do is we assign serial number to the respondents that are actually responding our questionnaire or actually responding our questions. Alright, so but the important point which is worth mentioning here, because of which nominal scale has a basic flow into it, that is that these numbers do not reflect the characteristics possessed by project or objects. Now what would that mean? If a student is given a roll number of 1, if a student is given a roll number of 10, now that does not mean that someone who is bearing a roll number of 1 would be better or isn't handsome or is more intelligent or is more vulnerable or whatever you may call it than someone who is bearing a roll number of 10. It has not to do anything with the characteristics of the object or of the individuals. This is only meant to identify or to classify the objects. Alright, so this is nominal scale for you. Now coming on to ordinal scale. Ordinal scale is a ranking scale where we do give ranks, and when we talk of ranks, it becomes quite obvious that we will talk of order. So the first job that one do whenever going to apply a ordinal scale, that would be to arrange, right? Arrange is an important word, to arrange the respondents in some specific order, maybe descending, maybe ascending, and then you will give a rank, or automatically it will be a ranking thing. So this is ordinal scale for you. Now this ordinal scale, a rank, suppose someone given a rank of 1 in a race, we can identify that individual by his rank, and hence it has the properties of nominal scale. Alright, and it also talks about some characteristics. Now the thing which was missing in nominal scale was that it was not telling us something about the characteristic of an individual. But this thing, ordinal scale, also bears the information relating to characteristics of the object that we are trying to measure. So a rank of 10 would mean he is far below than someone who is of rank 2. Alright, so it also tells us about that this characteristic is more in this individual and is less in that who's got a rank of 10. Alright, now there is one more thing to it, that the measurement that we talk of, all right, the measurement that we talk of in ordinal scale may be anything. What do I mean by that is, so if I have to go back to my Excel sheet, right, I would say if I am doing ordinal scale, right, so this is A, this is B, this is C, this is D, and this is E. So I may give him a rank of say 1, 2, 3, 4, 5. So that means that A is best out of this and E is worse out of this. So I would have also said 1001, 2001, 3001, 4001, or maybe 4022. So this is also something which is known as ordinal thing, because since we only come to know using an ordinal scale that the characteristic bear by any object, all right, is more in someone who's got a good rank than that individual who's got a bad rank. But one of the flaws of ordinal scale is it does not tell us that how much A is better than E. We know A is at 1, E is at 5, but we do not know how much better is A from E. The gravity of this betterness is actually something which ordinal scale does not talk about. So we know 3 is better than 4, but how much 3 is better than 4? Now if 3 has scored a mark of 68%, all right, and if D has scored 67.99, all right, still he gets a rank of 1, he gets a rank of 2, right? So we do not know. This just tells us this is better, and that would also be the case if he scored 90 and if he scored 10%. So still he is at 1, still he is at 2. So there is a huge difference, and this is a huge flow that we are talking about. So if you talk of the difference here, so difference is huge and difference is of 80, all right, and if you talk of this thing, then difference is very less, right? So this gravity is very important for us to understand whenever we talk of any scale. So when ordinal gives us an information, gives us an important information that which one is better, which one is not better, or which one is less better, but at the same time it does not tell us which one is better by how much extent, which is actually very important for us to understand. So this is a flow for ordinal scale, which actually was addressed when we started talking about interval scale, right? So interval scale, actually what does it do? Interval scale equals the distance of scale representation. Now it is something which has to be understood well, and it does not only tell us that which one is better by how much, but it also tells us which one is tell us from another individual, but it also tells us that how much he is better than someone who is not getting this thing. So meaning thereby, if I can go back to this Excel, if I can go back to this column, I would say in interval scale, right? So I would say that 1, 2, 3, 4, and 5. All right. So 1 represents strongly disagree. All right. So 2 represents disagree. 3 represents neutral. Right. 4 represents agree. 5 represents strongly agree. Now suppose this is an example of interval scale, right? So question is, I like NU, NIT University. So you as a respondent would either click onto this 1 or 2 or 3 or 4 or 5. So suppose you say I strongly agree, and you will say this is the case, which is 5 for me. All right. So now the important thing here is this clicking of 5 does not tell you, or does not only tell you that yes, you agree with this statement, but it also tells you if someone has clicked on to 1, that how much do you like NIT University as compared to someone who has clicked on to 1. And that is because these distances are kept constant in interval scales. That would mean whatever is difference between 2 and 1, all right, so that is something the same difference will be there in between 3 and 2. So this will be 1 and 1. So 1 here would mean 3 minus 2. Alright, so this one would mean, this blue means 4, green means 3. So 4 minus 3 is again 1. So this thing means blue 5 and green 4. Again this is 1. So this, when this thing is kept constant, which is difference between, alright, the two things that are part of our scale, then that forms interval scale. So now you can say that 5 is maybe 4 times better or 4 times more agreeing than someone who is saying 1. Alright, so this is how we also talk of the gravity, the magnitude, the extent of likability of someone of NIT University. So this is interval scale. So the property of interval scale would mean that these things has to be kept constant. Whereas if you would have noticed in ordinal scale, I have said 4000 and 4022. Whereas difference between this thing and this thing was 1000, and if I drop it down I will find that it is kept constant till 4, but here it is disturbed. So when it is disturbed, it no longer becomes an interval scale, it is an ordinal scale, right? So had I have deleted this thing and if I would have made it in red, I would have had only 4 options, which is 1, 2, 3, 4. Now I could have easily called it an interval scale, because the only difference between an ordinal scale and interval scale is that this gap is kept constant. Because when this gap is kept constant, actually we can subject this gap to mathematical analysis. That is an important word. But when this gap is disturbed in 4 and 5, so this is 22, earlier it was 1000. So when this gap is disturbed, I cannot subject it to mathematical analysis. I can subject this thing to certain tools and techniques which actually are only meant for interval scale or for ratio scale. Alright, now this thing can only be subjected if you are making E part of this thing. Now that makes it an ordinal scale, and you can only subject it to certain phenomena which actually requires, or which has its own assumptions about ordinal scale. But most of the tools and techniques that we talk of statistics, actually it requires some mathematical calculations to be done, which are quite obvious and simple, and these are actually subjected to this scale, which is interval thing. So 1, 2, 3, 4, 5, the only difference being that this difference has to be similar. The same way as we have taken above example, if I can shift it upward, now if this 1 would have been 21, now let's make it 31, let's make it 41, let's make it 51, let's make it 61. Alright, so same way if I can do it, so if I can actually do this thing, now suppose this thing minus this, alright, and if I can do it, see, in all the difference is 10 only. So this still fulfills, you know, the kind of requirement of interval scale, which is that interval between 2 points has to be equal. Now that is property of interval scale which has to be followed if you at all have to call it an interval scale. This is interval scale for you. Now, but one of the important points to talk of an interval scale, when I was over-sightedly talking about these 4 scales in the beginning of our today's talk, then I said one thing, if you can recall, and that was that this is not absolute thing, which means one of the important thing to notice about this scale is that 0 is arbitrary, right? 0 is arbitrary. What do we mean by 0 is arbitrary? Which means that we do not know where is 0, or we can make 0 anywhere. Which means if we say that 0 is 0, or if we say 0 is absolute, then you see these two things by means of interval scale, it is important to understand that these two things by means of interval scale are equal, right? So this is also equal, right? So these both are equal if you talk of interval scale, because 0 is arbitrary. So if you would have fixed 0, which means if 0 would have been absolute, in that case 1 would have become 1 in absolute sense and 10 would have become 10 in absolute sense, right? So which means if 0 is fixed at 0 only, then 10 would have meant 10, which are 10 units. 1 2 3 4 5 6 7 8 9 10. So 0 is 0, which is fixed. Whereas here it is not the case because 0 is not fixed. So for me 1 is equal to 10, right? 1 is equal to 10, right? So this is, I can make it green in case of interval scale, right? In case of interval scale. But 1 is not equal to 10, right? So let's make it red. 1 is not equal to 10 when we are talking of ratio scale, right? Ratio scale. So because this is 1 only, but this becomes 10, means absolute 10. So just to give one example, now if you say that my age is 20 years, now that is a pure ratio scale because you say 20 means absolute 20, right? You are 20 years of age, all right? But if you have to measure the same thing into interval scale, you would have said, you could have marked 20 as 50 also, all right? You could have started your scale as 10, 20, 30, 40 and 50. These are arbitrary numbers, 0 is not fixed, all right? So this is something which is interval scale. So these two things are equal in interval scale. The same way you could have had, instead of here as 3000, then 4000, then 5000, then 6000, then 7000, in that case the difference between all those would have been 1000, which is the only condition of interval scale to be fulfilled. So when the intervals between 2 points in a scale are equal, then we call it an interval scale, right? When they are not, then we do not call it as an interval scale. So now, is it making sense to both of you? Are you understanding? Okay, that comparatively is an easy thing to understand. So now we go to something which is a ratio scale. Now ratio scale is an absolute 0 point, all right? So which means that if your age is 20 years, then your age is 20 years, right? You cannot do much about it. I mean, it is 20 because 0 is fixed. So if, when you count it from 0, then it becomes absolute 20. Now that is something which is a 0 scale, which is a ratio scale. So ratio scale is something that can be actually subjected to any kind of tools and techniques and analysis. Now the reason being because it follows all the laws of mathematics, because mathematics starts from 0, all right? It has a standardized rule that things will start from 0, will go to 1, then will go to 2, then will go to 3. So in mathematics, which is considered as the purest form of science, 0 is fixed, all right? So when 0 is fixed and then numerals go on, so whatever mathematical operations that we can do, any numericals, the same can be subjected to something which is a ratio scale, because in ratio scale also 0 is fixed. So when 0 is fixed, when you say you are 20 years of age, you are not only telling that 20 years of age, 20 years is my age, which is an absolute thing, but you are also telling that I am older than someone who's a 15 years of age. So that ordinal factor also comes into picture, that interval thing also comes into picture, and hence ratio scale bears characteristic of all the four scales that we talk about, all right? Now this is an example which actually talks of all the four scales, right? So we have this nominal scale. So these are the stores, Lord and Taylor, Macy's, Kmart. So this is the number which is given to them. So this number also can be taken as the nominal scale, because now we know when I say that when it is 5, it is JCPenney. So this is a nominal thing. Ordinal thing, we say it is an order. So you say JCPenney is 1, then you say after JCPenney comes Macy's. In the same way as we have discussed onto Excel, no one stops you if you call it as 10 and then you say that second number is 25. Alright, so here the lower the number, better the thing is. Alright, so the 10 rank here, which is of Walmart, this 10 here is 115 here, and that conveys the same meaning, because we know that 115 is better than 53, right? So is better than 53, and we also know that 10 is better than 5. So this both bears or the conveys the same kind of results. That is ordinal scale for you. And here is it, a preferential scale, 1 to 7 and 7 to 1 to 7 and 11 to 17. Now these both scales, you see that 1 to 7 the difference would be same, so 2 minus 1 would be 1, 3 minus 2 would be 1. Same way 17 minus 16 would be 1, 16 minus 15 would be 1, and hence that doesn't make a difference. But when you say the dollar spent in last 3 months, that will be an absolute thing, and this is a ratio scale. So this is basically a difference between all those four scales. Now if you have understood these, all the four scales, then I have a question for you, right? So I would like to ask something. If you have understood these four scales well, did you understood? Manjula is responding. Example of interval scale on the slide is not clear. Okay, I'm getting back to slide. So here I'm coming at, and this is interval scale. So example, Manjula, is that here I'm talking of 1 to 7. Now suppose, as in Excel we have taken the example of 1 being strongly disagree, 2 being disagree, 3 being neutral, 4 being agree, and 5 being strongly agree, right? So the only idea here is that this gap is kept constant. All right, this gap is kept constant. Now just to give you a little more feel of it, now let's see. Now first rank, all right, is of JC Penny. I am now talking of ordinal thing, and it is 10, right? Fine. Okay, now just would like to understand that the 2 rank is here, all right, and here it is 25. So this is an ordinal thing for you. Now we were talking of interval in between. So this interval is how much? This interval is of 15, right? So we have 15 as interval in between, say someone who is 10, or someone who is 25, or maybe someone who is 1, or someone who is 2. All right. Now if I take difference between 2 and 3, so 2 is here, 3 is here. So the difference between 25 and 30 is 5, right? So this is difference between these two. So obviously this interval of 5 and 15 are not equal to each other, right? So this is how this is not an interval scale. But here, now suppose they have given 7 to 10, that is okay, no issues. Then they would have given 6, they would have given 4, they would have given 7. So here in interval scale, when you say it is 1, it is 2, it is 3, it is 4, 5, 6 and 7. Now that only means that this difference between 6 and 7 is equal to difference between 2 and 3, right? 2 and 3. So which means that if you have a value of 6 clicked, now you can actually tell how better 6 is from 2. So if this is 7 for this individual, preferential ranking for JC Penn is 7, and if for Rich it is 3, for it is 3, now we can see this difference as 1 only, and that would be taken as 1. That is the only difference. But whereas this difference would not be taken as 15. That is difference between a interval scale and an ordinal scale. So I hope it now makes sense. Okay, so now the question for both of you, Vijendra and Manjula, is that you remember those 4 things which we have discussed in previous talks. Those were the measures of central tendency, and measures of central tendency were mean, median, and mode. So now you have understood the scales well, so you've understood their properties also. So I would like you to tell me now. See, one more thing, let me clarify to both of you is that whenever we are trying to generalize anything, we are doing nothing but we are trying to achieve or approach at the central tendency of something, right? So when we have to do central tendency, now suppose I have measured something nominal scale, right? Repeating the question, suppose I have measured something on a nominal scale. Now which measure of central tendency can I subject this data? Suppose if I measured something on say interval scale or ratio scale, which measure of central tendency can I subject it to? Now suppose if I measure something on ordinal scale, which measure of central tendency can I subject to? So the simple question is, just repeating very quickly, that which measure of central tendency would you apply for nominal data? Which measure of central tendency will you apply for ordinal data? Which measure of central tendency will you apply for interval and ratio data? So what will be for nominal? Let's start for nominal. So will you use mean, will you use median, or will you use mode? Nominal is mode. Bang on target, Manjula. Very right. And what about ordinal? Nominal is mode. That is right, because interval is mean. That is very right, Vijendra. Rightly said. What about ordinal? Only thing left is ordinal now. Nominal and interval are right. So what do you think is right, Manjula? Ordinal has to be median only, because when we talk of ordinal, we talk of order, right? And when we calculate median of anything, just let me explain this a little bit to you. Maybe it is important that when we talk of a median, right? So this is 4, this is 2, this is 3, this is 1, this is 6, this is 7. Now if I have to get a median of this, then I have to arrange them in some order, which is maybe ascending, maybe descending. All right, so this has to be 1, then it has to be 3, then it has to be 4, then it has to be 6 and 7. So then I would say median is this thing. So when I'm talking of order, so for order we have seen the kind of thing is ordinal scale. So that is why we will go for a median when we are talking on ordinal scale. So measure of central tendency for ordinal scale would be median. Very right. We have explained it also. And for interval scale, ratio scale, we will go for mean, because it considers every entry of data. And then when we talk of mode is something which is repeated maximum number of times. So nominal data is something that we cannot subject it to mathematical tools, mathematical analysis, because how would one subject a name which is a nominal scale to say addition? So I mean, you cannot add two names, it will not mean anything. So that is why you cannot subject it either to a median or either to a mean. So the only scale of central tendency that is left for nominal is mode. So that is how we do it. So just last thought onto this scale thing is, so when we have talked about this thing, why interval and ratio scale is called as metric scale, and why nominal ordinals are called as these things. So when we talk of interval scale and ratio scale, as they can be subjected to any of the mathematical operations, so that is why they are called as metric scale. And they are also called as continuous scale. So why do we call them as continuous scale? Is because when we talk of a ratio scale is a continuous scale. So which means that if you are 20 years of age, so 20.1 is also possible. All right. So there is no break in between. All right. So which means 21, 22. So there is no break in between. So which means a value of 21.01 even is possible. All right. So that is why it is a continuous thing. 21.1, 21.2, 21.3, that is all possible, and that is why it is called as a continuous scale, right? Non-categorical scale, because categories, when you say categories, you're talking of watertight compartments. You're talking of one as a category, you're talking of two as a category. So you say that one is male, two is female, there is nothing in between, right? So that is something that we call as categorical scale. So even in nominal scale, we take gender also as a nominal scale. So we say male and female. That is, if you remember in a nominal scale, we have talked, it is used to classify the objects also. So when I classify objects on gender, male and female, then I would be using a categorical scale, which is a nominal scale, right? And when I'm talking of this nominal scale, essentially they are categories. Male is a category, female is a category, and that is why they are known as categorical scale also. And why they are non-continuous scale? Because if one is male, two is female, there is nothing in between. So a value of 1.1 is not possible. And that is why it is a non-continuous scale. There is no continuity in between. Alright. The same way, which is interval, that is also known as non-categorical scale. There is no categories. I mean, the value of 1.5 is also possible if I'm talking of either interval scale or either a ratio scale. So that was last thing that I wanted to discuss with you. So I hope it made sense, right? So next time we would like to talk about something which is a questionnaire formulation thing. All right, so next time we will do it. So today's talk understood? Okay, Vijendra says 5:30 to 6:30. That I think, Vijendra, perhaps will not be possible for me because from next week I will be engaged in something. So I was thinking of keeping the same time next week also, because I have next week only to complete these sessions of yours. Uh,